Happy Valentine's Day, everybody. My name is Nick Rubin. I'm with the GEOS team, and today we have Stephen Akuffo and Curtis Edwards from the GEOS team, and we are going to talk about how we size using the Apex Cloud Sizer for Apex private and hybrid cloud services. We're also going to talk about how applications have changed and what things we need to consider in the sizing process. And because of the nature of today's content, we are going to take a little bit longer than our usual video time, but I encourage you guys to hang in there. We got some really good content today. I think you're really going to enjoy what we have to say. And so to kick it off, I'm going to pass it to you, Curtis. How do we size for workloads leveraging the Apex Cloud Sizer?
Well, if our viewers remember from our last episode, Nick, you ran through the Apex console. And I'm going to share my screen right now, and we're going to jump back into that console, and I'm going to showcase where in the console the sizing takes place, or where it can take place is a much better approach here, right? So we're talking about Apex Private Cloud. Excuse me. And if you land on the console as an external customer or partner, you can then come over to the Apex Private Cloud or Hybrid Cloud or even Apex Cloud Services with VMware Cloud and start to configure the solution. As you start to configure the solution, it's going to ask you information on an order name. I'm just going to call it Apex Demo for right now. And then it's going to ask you what country you're in, right? So the country is just going to help you determine the pricing. So it reflects the pricing accordingly. Then once you get into that, it's going to start asking you questions in regards to how you want your first cluster to be named. But right above that, it is the Apex Cloud Sizer. Now, for many of our customers out there, this is probably going to be the easiest type of sizing they've come across, because once you open the sizer, it pretty much asks you 4 questions. The questions are, how many virtual machines do you need? Pretty straightforward. How much memory do you need per VM? How many CPUs per core? And how many vCPUs do you need per VM? Of course, the thing that you don't see on your screen here is capacity, but after you answer these questions, on the next screen will be how much capacity are you looking for, right? So it's pretty straightforward. And for the majority of our large business critical applications that are out there, this sizing is more than sufficient to get the environment up and running for an as a service solution.
So this seems like a really simple approach to sizing out infrastructure. It seems like there's just a few questions.
Yep.
So as we kind of go down the path with our customers of modernizing applications, more distributed architectures, like how does this impact the sizing process, and what do we need to consider when we actually are sizing for workloads like that?
I can get into some of that, because a lot of it is going to depend on how far along the digital transformation journey that our customers are in. So let me quickly show up.
So are you saying, Stephen, that my sizing is too simple for you? You want it to be more complicated?
Well, you know me, I'm always going to deep dive for no particular reason. But for most of our customers, it's actually more than sufficient. It's when they need to think about change, how the application landscape has changed over the course of IT. That's when we really want to start digging into these numbers that you're putting into, just large storage amounts, large memory amounts, and large CPU amounts. So let me quickly start a whiteboard session, and we'll go from there. Okay. So just to give a quick bring up, right? We all know that we've kind of transformed from this x86 physical era, where every application was essentially in its own server. And the reason this is important is that you also had to consider the physical implements of this. So your network card, for example, was a physical implement per physical server per application, right? You needed to worry about the operating system. You needed to worry about the data and application layer. Often these were going to be on separate RAID arrays. Often these were going to have a lot of the different hardware components that could fail or not. And you would just have to buy hundreds of them because every individual application needed its own physical server. This is the main thing the virtualization era simplified. And this is how we've been sizing probably for the last, I'd say, 5 to 10 years primarily, right? We've gone from having every individual physical server with all its individual components to the concept of a software virtual machine, where you can abstract away from that network, you can abstract away, what exactly the application data layout looks like on the individual system, and you can just worry about some few things: storage, CPU, and memory. And for the most part, for the last 5 years, as long as you've had these three values, VMs on your VMs, your storage, your CPU, and your memory, you could just create some sort of average from all of these values across however many VMs that you have, and that would be your sizing, right? So if you needed to get 100 gigs, let's call it, 200 megahertz CPU cycles and 16 gigs per application, you just multiply that by 100, whatever your total value is, that's how you size your environment. You just broke it up.
That's pretty close, Stephen, to what I was just showcasing, basically, right? You just take the averages of each virtual machine and you punch it in, and you end up with a size or a potential solution, right?
Exactly. And even this method has a lot of advantages, because you don't have to do things like wait for an individual network card. We used to have an era where the specific network card you ordered could destroy your application or save your application. That's been a long way away since we've been doing a lot of virtualization and abstracting that away. However, when it comes to digital transformation, something changes a bit, right? Because we're no longer simply talking about the idea of the VM. We're now thinking about the application itself. So if you think about what you typically hear when you're talking about digital transformation environments, you're going to hear things like Tanzu and Kubernetes. But even for traditional applications, you're going to start asking, well, we can't simply get more efficiencies out of the hardware because that's been shaved down to the bone. How can we look at the applications that we are running themselves to do rationalizations around them to see what actually needs to take up space in our environment? So what's that going to look like? Well, with something like a Kubernetes environment, you're typically going to have the idea of the worker node. The worker node becomes this large VM that essentially becomes a virtual server running other applications. And this will take a lot of the sizing, right? So this might look like a monster VM with a lot of CPU and a lot of memory and a lot of storage. But what it's doing that it's saving from the virtualization era is that rather than having to have all of the applications have their own operating system, have their own application layout, you now can just slot containers onto the Kubernetes worker node. And you just scale that out to however many nodes you want. What does that mean? How does that help you out? So rather than having to worry about the individual layers of your digital transformation as you're moving to containers, building CI/CD pipelines, and trying to build out these new distributed applications, you can still abstract most of them to VMs as long as you think about the distributed Kubernetes or Tanzu model, where rather than having every application take its own identity, you just merge it into the Kubernetes cluster. But if you don't have it that simple, if you are not even sure what the application is going to look like, or maybe you're thinking, hey, we have 10 web servers, all of them are VMs today, all of them are taking up 100 gigs, which means we are spending 1 terabyte on something that is just static web servers. You could break this down into a container and say, well, the payload for this is really just 125 megs. That's what the web page actually needs. So I'm going to carve this up into 10 instances that run on Kubernetes. And rather than charging your environment 1 terabyte for, made a mistake here, 1 terabyte for just 10 VMs, you can now do barely over a gig for the same payload. That is where digital transformation starts to help a lot with sizing and allows you to be more flexible with how you lay out your applications. So regardless of if you want to do it the traditional method of virtualization, where you have VMs and you just want to slap them onto the Apex resource pool, Or you have something like Kubernetes and Tanzu, and you want to start building out your environment according to those best practices, and you think about worker nodes and your management cluster. Or you really want to start breaking down your applications, start rationalizing them, and seeing where you can find efficiencies because of the advantages of digital transformation. You can do all of that on Apex by just figuring out how to slap it onto the cloud sizer.
Okay, so let's take a step back. Can we go back up the screen a little bit?
Sure, of course.
To the second part with the Kubernetes and the Tanzu right there. So in this case, our customers would be looking at that worker node and sizing the overall virtual machine and not the individual containers on that virtual machine. I mean, they'll have to do a little bit of homework first to figure out how many containers they plan to put on that virtual machine. But ultimately, in the Apex sizer, cloud sizer, they'll be putting in the construct of that worker VM, as you called it, right? Is that correct? Am I following you?
Right. And in this case, it might be as simple as if the customer has a great relationship between operators and developers. Developers might just hand them a YAML file, which will tell them exactly what needs to happen. And operators just need to worry about how big the VM is going to be, right?
Gotcha.
If they don't, they can work with the developers to do that backwards that you were talking about.
Gotcha. Okay, perfect.
All right.
This has been some really insightful information. Thank you, Stephen. Thank you, Curtis, for explaining to us like how we actually go through the cloud sizing process, what things we need to consider when we're talking about not only just traditional VMs and applications, but also when we start factoring in modern applications that leverage a containerized approach. I think speaking for a lot of our customers, it can be a pretty daunting task to think about, all of these workload types that could be potentially running on the same infrastructure, and there may be confusion or uncertainty in how we actually size for those things. So this has provided us with a lot of really good information, a lot of things to consider, and it actually oversimplifies and makes it a much easier approach. I think to when we actually factor in containers, right? We can run them in VMs, and it's just a collection of resources. It's just been really good. So I appreciate you guys walking through that.
Thank you. You know what, Nick? Also, for our viewers out there, they just need to keep in mind that even though we went through this, and we went through it rather quickly, right? Like you said, oversimplified it somewhat. The Dell teams are always here to help, right? So we're here. We can help bridge this gap of getting through the sizer or the minutia of the sizer, but just ultimately the sizer, from what Stephen has pointed out, from what I've pointed out, is straightforward and easy if you can kind of step back and just kind of think of things from a holistic perspective.
Exactly. So yeah, we will see you guys next time, and we'll get back with more information.
Absolutely.
Thanks.
Have a good day, everyone. Bye-bye.